Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. So today we've got Zainab. She has completed ROS 2 navigation, so she will be giving us a presentation on that. So first of all, what we'll see is a demonstration of a project on the real robot, then we'll get into the details about how she managed to do a project. Alright, I'll now hand over the platform to her so that she can begin a presentation. Alright,
Hello,
Zainab,
everybody.
whenever you're ready.
Yes. Good morning. I'm just getting my robot connected, and I'm going to start the whole process.
Alright.
But while it's connecting to the robot, I'm going to first test that the localization works,
Okay.
and then I'm going to perform the goals of the project, which is to make it move to a goal.
Alright. Alright.
Yes. So while it's connecting, it takes forever to connect sometimes. Okay. So I'm gonna be running my terminal. So the first thing I'm going to do is I'm going to check that the localization works.
Okay.
So I have all my command lines ready.
Okay.
So on this. Okay. Okay. And then I'm gonna prepare my RVs2 down. Okay. And then I'm gonna run my RVs2 so I can view. So I had already saved a previous configuration of my map. So I'm just gonna open that up.
Okay. Okay.
Yes. So it just makes it easier without having to do everything from scratch again.
All right.
Yes. Okay. So I'm going to set the initial pose first. The robot. Okay. So I'm going to try to move the robot, and then so if the particles are like gathering around the robot, that's how we know that the localization works.
Okay.
Um, so okay, let me move it. Let me put this down. Okay. So here I'm going to try to move the robot with my teleope.
Okay.
Yeah. Here. Okay. So this is my RVs. I want to see that it works. So I'm going to, oh, let me try to make sure that you can see my robot too. Okay, so that's my robot. Okay, so, okay. So in the map, we should be seeing that it's moving. Let me see, let me try it again, see if it works. Oh, okay. So here, that means there's a problem because
Well, it's moving slowly. I could see that on RVs
it's,
just a little.
okay, let me, yeah, AMC pulse. Okay, let me try now. Okay.
Okay, there we go. It's moving now.
It is moving, but for some, okay, I think it's getting better now. Okay. Okay, perfect. So now I'm going to be talking about that in the presentation later. But we had to create a script where we had the saved we had like locations, and we have the YAM file that has the position and their orientation. So I'm going to run that executable, and the robot is supposed to move to that spot. But before I do that, I'm going to run my path planning launch file. So I'm
Okay.
gonna go back. Yeah, I'm gonna go back here. open another one, and then run my path planning. Mhm. Mhm. Gonna do this. Okay. And I'm going to go back into RVs. I also have a configuration saved for that. So I'm just going to open that instead, and I'll probably have to just localize it again.
Okay.
So my path planning here. So the difference between my difference between my path planning and my localization was that I have added like a path display to it. So I'm going to initialize it
Okay.
first. The robot is somewhere there. Okay. And then I'm going to, sorry, change it back to AM suppose. Okay. Good. Okay. So now I'm going to run my my action script, which is supposed to take us to the goal.
Mm-hmm.
So this is my action script. So the first, so there were three spots we were supposed to go to in the project.
Mm-hmm.
So the first one is corner one, and then
Okay.
I'm going to do it. And if it works, I'll go to corner two.
All
And then
right.
the last one is the pedestrian bridge. Okay.
Right.
So yeah, one, interesting. Come back here. Should have like I should know the number of terminals. Okay, right here. So I'm going to run this. Control V. Let me hide this one. And then bring my RVs. Okay. So oof, this is it. So when I run this, it's meant to send a goal directly to RVs, and it's supposed to go to that corner.
Okay. All
RV.
right.
So
Yeah,
oh,
we
it
see
is kind of
it's
going.
moving. Yeah.
It is moving. Okay. Um, let me see. So it's trying to find a path, but I don't see it moving anymore. Let me check what the information in the terminal is saying. So this was what I was struggling with. I don't know. It says that it's done, but when I go to here, it says goal succeeded, which is weird. But let me try running for corner two.
Okay. Did you check that your
Yeah.
coordinates were right for corner one at least? Oh, so we see
Yes, I
also
did.
moving.
I confirmed. Wow. Oh, it goes. Okay.
So when
Oh,
it reached, it was the point itself. So you should be proud of yourself there, I think.
okay, it works. Oh, I don't know. I was so scared it wasn't gonna work. Okay.
All right, let's try the third
Um,
one and see.
okay, let's try the third one. Okay, the last one is pedestrian. Pedestrian. Moment of truth.
Mm.
Oh, it worked. Okay, I think I see what the problem is now,
All right, can you take us
but
through
I would
that?
explain later.
Yeah, yeah, it'll be quite interesting
Yes.
to hear what the
Yes, I
problem was.
see. I made a classical error.
Okay.
But let me wait for it to succeed. Okay, perfect. It works.
Mm.
Okay, I'm happy. Um, so the reason why it doesn't work was when I was if I go through my presentation real quick, I'll just talk about it.
Okay.
So this is the presentation, just a very short presentation.
Okay.
ROS2 navigation, the project. Just a little bit about me. My name is Zainab Aderoju, student at the University of Houston, majoring in electrical engineering, and I'm also taking this class as an elective. So the goal of the project is basically we had to map the robot. We had to map the environment of the robot,
Mm-hmm.
and then the next section was to localize the robot. So
Okay.
we wanted to make sure that the robot knew where it was in the environment.
Mm-hmm.
And then the third one was to make sure the path planning system was working.
Mm-hmm.
And then the last part was to make sure that we had a whole navigation system in place working. It's able to go to the goal and so on.
Yes.
So for my code setup, first part of my project, which was mapping, creating the map for the environment, I'm going to take you through the code on on the website again when I go back.
All right.
And then the next part of the project, we localized it using the AMCL node,
Mm-hmm.
the launch file. I'll also go through that.
Mm-hmm.
And then we also created a service server script that can save a spot's location whenever we call it.
Okay.
And then for section 3, we were just supposed to make sure that the path planning worked. We launched all the path planning nodes, the ET navigator, the planner server, the controller, everything.
Yes.
And we sent navigation goals through RVs too and made sure that it was working.
Mm-hmm.
And then for section 4, we basically created a script that so for me this felt like a continuation of section 2 in a way because we created a YAML file
Mm-hmm.
that had specific spots like I said, and then we use an actions client script to actually send the goal, not using RVs too.
Right. Yeah.
So that's just a quick presentation, but
Mm-hmm.
let me walk you through the code now.
Yeah.
So this is why I think I thought it wasn't working.
Okay.
So because I had specified the corners in section 2, what I did was, let me take you through it. I created a package, project nav2, and then I ran a configuration. I created a script. Let me show you the script. This is the script. Okay, so right here, spot recorder.
Mm-hmm.
So this particular script was meant to, whenever I run this script, I open my RVs too.
Mm-hmm.
I'm not trying to localize the robot. I'm just trying to hit the 2D estimate positions of where I wanted my robot to go to in path in like, with the action client script. So on the map, I just I did my RVs and I clicked maybe 2D estimate, clicked a particular point,
Mm-hmm.
and then it records it into a YAML file,
All right.
right? And then I formatted that file into this. So this is spot list. This is the corner one. This is the position,
Okay. Okay.
the corner two pedestrian.
So
So
you
my
made it in
mistake
ROS
was
parameters. Right.
what did you say?
You had to convert them to ROS parameters, right? So you can pass them to a node.
Yes, so that I can pass them through the node for my action client script. But
I
my
see.
mistake was for my corner one, I clicked on the wrong spot. So
Okay.
I clicked on the wrong spot in the map. So I thought this was my corner one, but this is
Oh.
actually my corner one.
Right.
So
Right.
when I kept running, it wasn't going there. And I was like, why aren't you working?
Mm-hmm.
So it wasn't
Mm-hmm.
until I presented right now that I realized that when I went to corner two, which was all the way on the other side, it actually worked.
Right.
But it was just a misarrangement of corners, but
Right.
it actually works.
You could
Uh,
call it
yeah,
classical, but yeah, well done on discovering that.
yes.
All
So, but
right.
let me take you through the action script.
Sure.
So this is what I basically did. So action client, I created my I created the I created a subscriber. So
Mm-hmm.
it was subscribing to my no, actually I created my client, right? And then I called the navigate to pose action. And so what I did was the first thing I wanted to do was to get the function, to have a function that reads the file that I saved my um previous like move orientation positions that I had already saved from the spot recorder.py.
Yes.
So I read it. So it's reading from after the point of move to spot ROS parameters, right?
Right.
And so it extracts those positions that align. And that's why in my command line, I
Mm-hmm.
have spot name is equal to corner one. So I've already specified the spot name. So it looks for the corner one in spot list,
Yes.
extracts those positions, and then publishes a goal um to the robot to go to that particular position. And so that's how we do it from an action script.
Right. Okay.
In the course, we also had you have a question?
No, it's fine. I just said okay.
Oh, okay, okay. Oh, okay, okay. I thought I said like okay, like and then ask the question. Okay. And then the next thing Okay, yeah, and that was basically what the script was doing, just extracting those spots and then reading them and going straight to them. For the spot recorder .py, what I did was we subscribed to a pose with covariance to the initial pose.
Mm-hmm.
So this was how we're able to extract those particular positions. And then every time I did that, I would save it into my file,
Mm-hmm.
which I named spot list
Mm-hmm.
dot yeah, and then I configured it, like I reconfigured the file by hand, because when I run this particular script, it it would give me just this information: corner one, orientation, position. So what I did was I reconfigured it by adding the move to spot and ROS parameters, just to make sure that it's a standard file.
Mm-hmm. Okay.
And then
Okay.
that was when I ran the robot action. As for creating the map, to create a map in ROS2, you basically run a cartographer node. So
Mm-hmm.
a cartographer node is the SLAM. So it's SLAM, simultaneous localization and mapping application for us too.
Mm-hmm.
So we use cartographer. We have another type. I think it's called SLAM underscore toolbox, I think.
Right. Well done. I
But we
was
use
gonna ask that
cartographer
one.
because it's easier.
I was
Uh,
gonna ask what's the other one. So yeah, you just answered my question. So well done on that one.
Yeah, so slam underscore toolbox, I believe.
Mm-hmm.
And so we do cartographer because I mean the course is that it's more robust and
Right.
like easier. So we use that. So what I did was I have my launch file. This is my launch file. I run the cartographer node, the cartographer occupancy grid,
Mm-hmm.
then I launch it, and then I open RVs2. And then, so in RVs2, it's important to note that you have to, whenever you have, for example, the map, you have to ensure that the QoS, like everything is the way it's supposed to be, keep all reliable, transient, local.
Mm-hmm.
For the other displays, they also have their own QoS
Mm-hmm.
settings.
Mm-hmm.
So for example, laser scan has best effort and stuff like that. So we did that. Then I used the teleop to move around so
Mm-hmm.
that the robot can use the sensor and read the whole environment.
Mm-hmm.
And then once we're done with that, we save the map running this command line. We save the map using this command line. So we go into where we go into the path that we want to save the
Mm-hmm.
files in,
Mm-hmm.
and then we run this command, which is the map server.
Mm-hmm.
And so that was what I did. I did that. I saved it into my project mapping. So, and that's why if you open the configuration, wait, I have too many stuff open.
Mm-hmm.
Okay, so when I have my configuration for my project mapping, I should have like two files. So this is what gives me information about my map.
Mm-hmm.
And then the next thing to do is to provide that map to other nodes. For example, how did I import it into localization?
Yes.
So that's where we always call the, so for the localization, this is where we call the map server. So this is what provides the map. And then we have the map file
Mm-hmm.
as the um as the path to the directory that we have the Turtlebot area files, the YAM file and the PGM file.
Yes.
So I think I've covered most of this,
Yeah.
but if there's any question you want to ask me,
Yeah, yeah. You
go ahead.
did cover most of the bits that I wanted you to speak about. That's that I was gonna ask about anyway. But I still have some questions I'd like to ask you. Um,
Yeah.
okay. Anyway, first of all, well done. Very clear presentation there. It shows that you do understand how things are moving within the nav2 stack, right? So that's very nice on your part.
Okay.
Um,
Okay.
I was gonna ask something along the lines of let me look for it. Okay, localizing, right? You localize the
Yes.
robot using RVs. Um,
Yes.
how else can you do that? How else can you localize it? Is there any other way you can localize your robot?
Yes. So for example, you know how I clicked on it? What you can do, so you don't always have to do that every time you open up the configuration.
Mm-hmm.
What you can do is if I know that the robot is always gonna be in this particular position,
Mm-hmm.
exactly what I did for the spot recorder.py, where I just ran RVs.
Mm-hmm.
I wasn't trying to localize, I just clicked on the spot. You can, so in the RVs2 terminal, whenever you click on a spot, it gives you
The
it
coordinates.
gives you, I don't know if I close it, it gives you the coordinates exactly.
Yeah.
So you can save those coordinates and then write them. So in our localization launch file, we have something called like the AMCL.
Mm-hmm.
So the nav2 YAML in this particular one,
Yeah.
we have a particular position where we can say, okay, let me look for it. It's at the bottom.
Yes.
You can add the set initial pose and it becomes true.
All right.
And then you just put in the X, Y, and the your positions. And
All
so you
right.
can have that. And every time you load, you don't always have to
You don't, yeah,
initialize
okay,
the
that's good, that's good,
position.
yeah, very good answer there. The other thing I wanted to ask you about is when you use the AMCR, right, you have to specify number of particles. Can you tell me or get me through what is the purpose of those particles, right? And what does it mean when you change the number? You either increase it or decrease it. How does that affect your localization, for example?
Um, fortunately, I actually glossed over that kind of in the course, so I
Give
don't know
me
if I
give me
can
what you
really
think.
answer that question.
Give me what you
What I
think. Yeah,
think.
yeah.
Mm, okay. For the wait, give me just 1 second. Let me actually try to think about it. Because I see like the max particles and the
Mm-hmm.
mean particles
Minimum
here.
particles,
Did say
yes.
that. Mm, I
Okay.
guess what I would say, for example, is when I was talking about how the localization works,
Yes.
and the way we know that it works is when it's just standing there, it's dispersed. And so, but when it's moving, we want the particles to be like in clusters around the robot.
Mm-hmm.
So I guess the larger the particles, the no, the smaller the particles, the harder it is to identify exactly where the harder it is to like keep tracking the localization of the robot, or
Right.
maybe vice versa. But I think the particles determines how wide the the robot is able to localize itself
All right.
in
So,
the environment.
okay, I think you're on the right path. Okay, the relevance of the particles is they are like sampling points, right? So, the more
Um,
samples you take, the more accurate your localization algorithm gets, right? So, if you give your
um,
AMCL more sample particles, right, it's gonna be more accurate on figuring out where exactly the robot is, right? So you are on the right path.
yeah,
It's just that some details were not quite in place. But yeah,
yes.
well done for trying to explain it, right? All
Yes.
right. I think that's it on my part in terms of questions. So, very well done,
Okay.
Zainab. I liked your presentation. It was clear. Let's just polish
Thank
up
you.
on what do the particles really do, right? So, but well done,
Yes.
well done. It's a very nice
Yeah.
presentation.
Thank you very much.
All right, so we'll wrap it up here and just hang on. We'll finish our conversation on Zoom, okay?
Yes.
All
And
right,
this
everyone.
here.
So this was Zainab's presentation. Very well done to her for taking us through the nav stick and also demonstrating it on the real robot. And it did work this time, so that's quite good on her
Yeah.
part. So other than that, we encourage all of those who would want to take some of the courses we offer certification on to go for it, and then you can come and give your presentation. It will reinforce your learning. So until next time, keep pushing your ROS learning. Bye bye.